Let me give you an example to help you solve distance displacement related questions. Imagine a park wherein there is a rectangular track for walkers. Let us mark the corners A, B, C, T. This park has a dimensions of 80 meters here and then 40 meters here. Let's consider different situations. From A to D or A to A. That means the person walks one complete track. That means he starts from A, he enters into the park at A, he goes to B, C, D and A. He has come back to the same point. From A to A, one complete walk around the track. From A to A, distance is the actual length of the path traveled, so it is 40 meters plus 80 meters plus 40 meters plus 80 meters. So it is 40 plus 80 plus 40 plus 80, which is 240 meters. Whereas displacement is 0. Because he has come back to the same point, the distance between the initial point and since the initial and final points are the same, the distance between the initial and final points are 0. The shortest distance is 0. What is the distance and displacement from A to D? The person starts the next round, he starts from A and he goes to D. So the distance is 40, the actual length of the path, right? So it is 40 plus 80 plus 40. So 160 meters. So distance is 160 meters, or in other words, I will write it as 40 plus 80 plus 40 meters. So it is 160 meters. But what is displacement? It is the shortest distance from the initial point to the final point. You have to connect it with a straight line. If you connect it from initial point to the final point, so the displacement is just this length, which is 80 meters. So we have just seen two cases. One is for complete walk around the track, and then it is 3/4 of the walk from here to here to here. And the last case, what is the distance and displacement from A to C through B? When he walks from A to C through B, so he has to walk like this, right? So the distance is 40 plus 80, so which is 120 meters. But the displacement is the shortest distance or a straight line distance from the initial point to the final point. If you connect the initial point to the final point with the help of a straight line, you would see this is a right angle triangle with largest side being our displacement, and these two sides are 40 and 80. So displacement here is, since it's a right angle triangle, the hypotenuse side will be root over this side square plus this side square. So 40 square plus 80 square. So root over 40 square is 1600 plus 80 square is 6400. So you can write it as, let us say 0, 0, 0, then 8. Root over 8000. So you can write this as 80 into 10 power 2. And 10 power 2 comes out, it becomes a 10, so it is 10 root 80. So you can further simplify this. I'll stop like that here. So the displacement here is 10 root 80 meters. So this is how we calculate distance and displacement. So I will be giving some problems related to circular tracks and square tracks. So try practice some problems so that you will get to grips with distance and displacement.